Hello everyone, it's Ms Redmond here and welcome to your fifth and final lesson in the sound topic. This one is called How Can Sound Be Useful? If you haven't got one already, please go and get a pen and a piece of paper so that you can make notes and do any little tasks that I set you as we go along. You've got your success criteria at the bottom here, so feel free to pause the PowerPoint and write those down. Okay, let's have a look at this slide. So we've got some pictures of H7, which is the drama studio nearest to my lab. How does your voice sound different in H7 compared to lab 6 and why? I notice this as soon as I walk into any drama studio. The sound in there is completely different. Hopefully you've noticed that as well. So pause the video and write down any ideas and then I'll tell you why. So the carpets and the blackout blinds reduce the reverberations in this room. So reverberations is when you've got lots of sound waves bouncing around in all directions. So in lab 6, there's lots of windows and there's hard furniture and we've got hard flooring instead of carpet. So there's a lot more echoes or reverberations in lab 6 than there is in H7 or in any of the drama studios. Okay, you can measure the time taken for a sound to echo back to you and then use the speed equation to work out the distance that the sound has travelled. Divide by 2 and you have the distance from the wall. So this is something which often comes up in exam papers. The idea is that you stand far away from a building, a large flat surface, and you make a noise and then you time how long it takes for the echo of that noise to come back to you. So let's have a look at the calculations for how you would actually work this out. So for example, the time taken to hear the echo is 1 second. So we can use the equation distance equals speed times time. We'll get into speed, distance and time in more detail in year 8. So this is a little preview. So therefore, if we plug the numbers, the values that we know into this equation, we can work it out because we can remember from a previous lesson that the speed of that sound is 340 meters per second. So we've got speed here, so we've got 340 meters per second here. And the time taken, we're given in the question, is 1 second. So we've got 1 second in here. And so the distance travelled is 340 meters. But that means that the sound wave has travelled from the person to the building and back again. So it's travelled 340 meters. But it's going in 2 directions and we want to know how far this person is from the building, so we do the distance to the wall is distance travelled divided by 2. So the distance to the wall is 340 meters divided by 2 equals 165 meters, which is what we've got here. Now there's a lot of problems with measuring distance in this way because human beings have what's called a reaction time. So if you're trying to time this with a stopwatch, you're going to be measuring the time that it takes the sound to travel there and back, but you're also including in that time how long it takes you to press the stopwatch. So it's very, very inaccurate. And also sometimes it's quite hard to hear the sound and it's actually quite unusual to be somewhere where there's just one building in front of you to get one echo. So if you think about our school site, if you went and shouted in the playground, you would be able to hear echoes from all of the buildings around you. So there are issues with trying to do this practical. And I've just explained them. Okay, however, bats and dolphins are really, really good at using this principle to sense the world around them. So bats send out very high-pitched clicks, or no, they don't. They send out very high-pitched squeaks, and dolphins do clicks and squeaks, and they are able to detect those sounds returning, and they're able to time very accurately how long it takes, and that allows them to sense the world around them. So they can almost build up a visual picture of what's going on, and that's important because bats are active at night time when it's dark, so they can't use their eyes, they have to use something else. And dolphins live underwater, and it's often quite dark down there, or it's there's lots of stuff suspended in the water, so it's very hard to see. This link at the bottom is to a YouTube video which explains it much better than I've just done. So we can use ultrasound to detect things inside the body. Ultrasound are sound waves that are too high pitched for humans to hear, so they have a frequency above 20,000 Hertz. We've mentioned this in a previous lesson. And ultrasound waves reflect differently off different surfaces. So this lady's gone in for an ultrasound scan on her baby, and this wand here is producing the very high pitched sounds, and those are going into her body and they're reflecting off different surfaces. So the signal goes back into the machine, and the machine is able to build up a beautiful picture of her baby. And you can also use ultrasound to detect other structures within the body. And you can also use it to break down things like kidney stones, because, as we know, sound waves are vibrations. So if you cause a kidney stone to vibrate a lot of times per second, because you've got a very high frequency sound wave, you can actually break it up, and then the person who's suffering from kidney stones can pass the kidney stones and get rid of them. Sonar is also something that humans use. So sonar is an acronym, a very bad one in my opinion, because it stands for sound, navigation and ranging. So you picked out the SO from sound, the N from navigation, we've got and in there, and ranging, so sonar. Essentially what you've got is a ship, or you might have a submarine, and you've got a transmitter on one part of the ship. It sends an ultrasound pulse down into the sea, and it bounces back to a receiver on a different part of the ship, and it allows the people on the ship to build up a picture of the bottom of the sea. So it's very useful if you're looking for fish, or if you're looking for structures on the seabed that might give you an indication that there's some oil down there, for example. All right, have a go at this. Draw this table onto your piece of paper and try to fill in the gaps about echolocation, ultrasound and sonar. And I'll give you the answers on the next slide. So echolocation, who is used by bats and dolphins, where, bats in the air, you could add at nighttime, and dolphins underwater, why, to detect prey in the dark, and how, sound waves are emitted, reflected from the objects and then detected by those animals. Ultrasound is used by doctors or ultrasound technicians in a hospital or a clinic, and it's used to detect objects or structures in the body, for example a baby. Sound waves are reflected from structures and detected by a machine, then turned into an image. And sonar is used on boats, you might also have written submarines, underwater, and it detects objects in the water and or on the seabed. Sound waves are emitted by a transmitter and then detected by a receiver, and the information is turned into an image. Here's your summary slide. An echo is a reflected sound wave. Reverberation is when echoes join together to make a longer sound. Echolocation is the method used by bats and dolphins to detect prey and their surroundings. Ultrasound is used by doctors to detect structures in the body, and they are sounds with a frequency of over 20,000 Hz. Sonar is used on boats to detect the seabed. A transmitter sends out a beam of ultrasound, and the receiver detects the reflected ultrasound waves. Thank you so much for listening. That's the end of the sound topic, and I will speak to you in another video. See you in school. Bye bye.